A problem of one object doing one motion. The simplest case possible. So we have a car that accelerates from 20 to 100 meters in 5 seconds. What is the acceleration and the distance traveled? When we talk about time 5 seconds, we don't talk about the time interval, right? So we consider that it all started at time 0 and it ended at time 5. But we don't pay a lot of attention. So you should know that when it says this, it means a time interval. But we don't talk about it. Now, we talk about the distance, and just because this distance and displacement in this case is the same thing. The motion is towards the right, we have a positive velocity moving to the right. That's fine. The distance and the displacement are the same thing. So if you see the word distance, don't worry, it's the same thing, right? So how can we solve this? The first method is doing a graph, okay? So the graph is always the velocity time graph. Why? Because the velocity time graph gives information about acceleration and displacement. It has everything. So in this case, my velocity changes from 0 to 100 in 5 seconds. This is my velocity time graph. What is the acceleration? The acceleration is the slope. So I need to do rise over run. So the rise, the change in velocity, is final minus initial, so it's 80 meters per second, while the run, the change in time, is 5 seconds. So the acceleration is the slope, rise over run, which is 80 meters per second over 5 seconds, which is 16 meters per second squared. What about the distance traveled? Well, that's the area under the graph. And when we talk about the area under the graph, we talk about the whole area until the time axis. So we are talking about this trapezoid. All right? So this trapezoid can be solved either as big base plus small base in parentheses multiplied by the height over 2, or you can say, all right, I can split this into a rectangle and a triangle. So the displacement, the distance traveled, will be the rectangle and the triangle. So the rectangle is base times height, so it's 5 seconds times 20 meters per second, plus the triangle, which is half, can you see? Half base, which is 5 seconds times the height, which is 80 meters per second. So the displacement is, this is 100 meters plus, how much is that? 45 times 40 is, I guess, 200 meters. So we have a total of 300 meters. So this is how we, I don't know if you see it, 300 meters. This is how we do it with the graphs. Now, if I wanted to do it with the equations, what should I do? The best way to do it with equations is to start by making a table. Let's not call it table. Let's call it somewhere else, somehow. So, and we need to write down all the possible quantities. time, acceleration, initial velocity, final velocity, initial position, final position. Okay, there are always 6 quantities related. And we need to know all but 2. Why that? Because we have 2 equations. So, what do I know? I do know time. Oh, sorry, it's 5. Do I know acceleration? No. Do I know my initial velocity? 20 meters per second. My final, 100 meters per second. Do I know my initial position? No, but let's consider it as 0, so the displacement will give me the final position. So I know this, right? I know 4, I don't know 2. I'm good. I can use my 2 formulas, which are the formula that gives me the final velocity and the formula that gives me the final position. So what I can see is that what do I know from each one? So I know where to start from. So I know the final velocity, I know the initial velocity, I know the time, I don't know the acceleration, I'm good. Here I don't know the final position. I know the initial velocity, I know the acceleration, I know the time. Sorry, I don't know the acceleration. What am I talking about? I don't know the acceleration. I only know the time. So in this case, there are 2 things that I don't know. I don't know the position, the final, I don't know the acceleration. So I will start from the first one. So from the first one, I know that the final is 100 equal 20 plus acceleration times 5. And from this I can find that the acceleration will be 100 minus 20 over 5. So my acceleration will be 16 meters per second again. So I come up with actually the same thing that I found from the slope. I subtracted the 2 velocities and I divided with time. Now that I know acceleration, I can go back here and say, okay, so what's the final position? Initial position 0 plus 20 times 5 plus half times 16 times 5 squared. So, which is 100 plus 25 times 8. 25 times 8. 8 times 5 is 40. Times 5 is 200. So I come up with actually exactly the same addition that gives me 300 meters. So doing a graph or doing the formulas, it's exactly the same thing.